The question we are solving now belongs to test series 5. It is of signals and system subject. In specific, it belongs to basics of signals. As per the question, there is a continuous time signal given as x of t is equal to u of t minus u of t minus 1. We need to find the conjugate symmetric and conjugate skew symmetric parts of this signal in terms of another signal rect of t1 comma t2. The signal rect of t1 comma t2 is defined as shown. Rect of t1 comma t2 is a pulse from t1 to t2 and is of uniform magnitude in this range, and the same is equal to half. Now first let us find out the conjugate symmetric part, which can be given as half of x of t plus x star of minus t, where star refers to the conjugation. As the given signal is real, x star of t is equal to x of t. Hence, the conjugate symmetric part can be written as half of x of t plus x of minus t. We know that the given signal x of t can be drawn as a pulse in the range of 0 to 1. So this is the plot of x of t. So from this, the plot of x of minus t can be obtained as shown. That is a pulse in the range of minus 1 to 0. This is obtained by reflecting x of t around t is equal to 0. So from this we see that xe of t can be written as half of x of t plus x of minus t. That is, upon adding these two signals, we see that x of t plus x of minus t is a pulse in the range of minus 1 to 1. So, and this is of magnitude 1. So we see that the signal x of t plus x of minus t can be written as 2 times rect of minus 1 comma 1. This is because of the reason that the pulse is of magnitude 1 and it is present from minus 1 to plus 1. So upon simplification, this can be written as rect of minus 1 comma 1. So we got the conjugate symmetric part xe of t in terms of the rect function given. Now let us find out the conjugate skew symmetric part xo of t, which can be written as half of x of t minus x star of minus t. As the signal is real, the same can be written as half of x of t minus x of minus t. So we already have x of t and x of minus t. Now let us find out the difference between these two signals, that is x of t minus x of minus t, which can be drawn as shown. So from this we see that xo of t can be written as half of two times rect of 0 comma 1. This corresponds to the pulse that is present from 0 to 1, and we see that there is another pulse in the range of minus 1 to 0. So the same can be written as minus 2 times rect of minus 1 comma 0. Please note that we have put minus 2 because of the reason that the magnitude of x of t minus x of minus t is minus 1 in the range of minus 1 to 0. So based on this, we can rewrite the xo of t as rect of 0 comma 1 minus rect of minus 1 comma 0. So we got the conjugate skew symmetric part of the signal in terms of the rect function. So from this we see that the conjugate symmetric part and conjugate skew symmetric parts are obtained in terms of the rect function, hence as shown. Hence the correct option representing the conjugate symmetric and skew symmetric parts of the given signal is D.